In problem number 3, we're going to prove that the limit of 3x minus 2 as x approaches 2 is equal to 4 using the epsilon delta definition of limit or the formal definition of limit. Again, to prove this, we have 2 steps. And to start with the proof, let's do step number 1. To step number 1, okay, we're going to let me just do pen. We're going to let epsilon be greater than 0. Then we want to find delta, or the value of delta, which is greater than 0, such that by definition, right, the absolute value of x minus 2 is less than delta but greater than 0. And we got this from this, okay? Then, such that if, then the absolute value of the function 3x minus 2 minus the limit is less than epsilon. All right. Now, since our given is 3x minus 2 and 4, so we can use this. We can use this statement or inequality to find the value of delta, which is greater than 0, okay? Which means that we can simplify this or manipulate this inequality to express this in this form, the absolute value of x minus 2 less than delta, for us to find the value of delta. Okay, so now I'm going to copy 3x, our absolute value of 3x minus 2 minus 4 is less than epsilon. All right, so we're now solving for delta here. And we can simplify this. This becomes 3x minus 6 is less than epsilon. Okay, and we can factor out 3x minus 6. Again, why do we need to factor out? Sorry, we can factor out 3x minus 6. And again, why do we need to factor out by 3? Because we want to express this in terms of this to find delta. So we can factor out 3. So 3, the absolute value of 3 times x minus 2 less than epsilon. And I can factor out 3, which is the absolute value of 3 times x minus 2 is less than epsilon. Now, why absolute value of 3 when we factored out 3 from the absolute value? That's one of the properties of absolute value, okay? So the absolute value of 3 is 3 times the absolute value of x minus 2, which is less than epsilon. And we can divide this by 3. And again, why do we need to divide this by 3? Because we want an expression that says the absolute value of x minus 2 is less than delta. All right, so this becomes, okay, let's move on to the next. Okay, we got, let me go back. We got the absolute value of x minus 2 is less than epsilon over 2, correct? All right, now here we found out that we have already expressed the left-hand side in terms of the absolute value of x minus 2. And if we're going to review the statement that we have at the very beginning, so that's the absolute value of x minus 2 is less than delta, but greater than 0. And let me rewrite that here. Okay, let's use different color to, okay, to show that whatever we have here, comparing the given and the one that we just got. So we have the absolute value of x minus 2 is less than delta and greater than 0. So let's compare. Now let's use another color. Let's use white. Again, let's put this back to white. Now, the absolute value of x minus 2 is equal to the expression here. And we know that absolute value of a number is always positive. So therefore, this is greater than 0, right? And it can never be equal to 0 because x can never be equal to 2. Because it says here, x is approaching 2, but not equal to 2. All right, so we have already satisfied this. We have satisfied this one. And the inequality also are the same. Both are less than. And of course, when everything is equal to one another, then this one or this expression is also equal. So we could say that delta is equal to epsilon over 2. So we have already found the delta in terms of epsilon. That's epsilon over 2. Okay, so let me just check. Oh, actually, it's over 3. All right, sorry, my bad. So this is over 3, and this is over 3. So delta again is equal to epsilon over 3. So we have already found the value of delta in terms of epsilon, okay, which is epsilon over 3. And let's go to our next step, which is step number 2. All right, so in step number 2, we're going to show that, okay, for every epsilon greater than 0, then there exists delta greater than 0 such that, all right, the absolute value of x minus 2 is less than delta but greater than 0, then we have the absolute value of 3x minus 2 minus 4 is less than epsilon. All right, so we need to show that this inequality exists using the statements here. All right, the given. So here, we know that this is one of the givens. All right, so this one, and we can use this for us to show that this is true. So let's use this one. Again, I could say that the absolute value of x minus 2 is less than delta. And for sure, this is always greater than 0, as I explained earlier, because x or absolute value means positive, or the distance, all right, between two numbers. And it's always positive or equal to 0, but it can never be equal to 0 because x is not equal to 0. Because it says here, it approaches 0, but not equal to 0. So therefore, what would I do with this statement to get this statement or to express this statement to this? So for me to do that, I could multiply this by 3 both sides. So 3 times x minus 2 is less than 3 delta. Why 3? Because the x here has a coefficient of 3. All right, that's the indicator of what number to be multiplied to both sides. Okay, and I could now, or I could simplify this by putting 3 inside the absolute value. So I could have 3 times x minus 2. Okay, it's less than 3 delta using the property of absolute value. All right, and let's move on to the next slide. So take note of this. Oh, sorry. So let's try to rewrite the last expression. We have the absolute value of 3 times x minus 2, sorry, absolute value, less than 3 delta. Let's check. Oh, sorry. Yeah, correct. 3 delta. Okay, here we go. And let's simplify this or express this on the expression that we wanted to be expressed to. So we have 3x minus 6 is less than 3 delta. All right. And however, again, we want to express, okay, let me just write the expression that we wanted this inequality to be expressed to. We want this to be expressed as the absolute value of 3x minus 2 minus 4 is less than epsilon. All right. This is our main goal, to express this inequality into this for us to show that it really exists. Okay, and it is really true. Okay, so we have 3x minus 2 minus 4. right? Because -2 minus 4 is equal to -6. So they're just equal. We just played with the given terms here inside the absolute value. All right, so we have 3 delta. Okay, so let's copy 3x minus 2 minus 4 is less than 3. And again, we want to express this in terms of epsilon. And we know that delta is equal to, delta is equal to, let me just erase this, epsilon over 3, right? Okay, epsilon over 3. And how did we get epsilon over 3 again? Let's go back here. We got delta is equal to epsilon over 3. So by substitution, okay, we have that and we can cancel this out. So therefore, our expression becomes the absolute value of 3x minus 2 minus 4. All right, this is parenthesis, is less than epsilon. So we have already proven, we have shown that we can express the inequality, uh, the absolute value of x minus 2, all right, is less than delta to the expression, the absolute value of this is less than epsilon. Okay, so since we have already found out, or we have already proven, okay, let me just change the color, that we can express it in this manner. Okay, let us go back. All right, so we want to express it in this manner, and we did that with this. Okay, so therefore, we can now say that the limit of 3x minus 2 as x approaches 2 is equal to 4. Therefore, the answer is really 4. All right, using the epsilon delta definition of limit.